And so we're going to answer our questions in that chat box today since there's so many of us. So you guys are going to have to think about some of the stuff that we talk about today, all right? So here, let's get started. All right, everybody, hopefully you can see my screen up there. So we're going to be talking about the Hoover Dam today, and I work at the Herbert Hoover Presidential Library and Museum. We're part of the National Archives and the Presidential Library System. So you guys should check out the National Archives while you're home and learning about stuff. We have lots of really cool stuff. So I got to visit the Hoover Dam last year. It was super exciting. Have any of you guys been to the Hoover Dam before? You can go ahead and type in that chat box if you have. You can see I'm standing in front of it, and I got this awesome Hoover Dam t-shirt while I was there. And so we're going to talk a lot about the Hoover Dam today and talk about why we build dams and what they do. So let's start there. Why do we build dams? What do you guys think? Share some reasons in the chat box. We're going to take 2 minutes. I want you guys to put on your thinking hats and really think about why we build dams. What do they do for us? I'm seeing some good answers: providing electricity, energy, flood prevention, controlling water supply. Yes, these are great answers, guys. So it reduces or prevents flooding, just like you guys said. It provides hydroelectric power, so we can generate power in those hydroelectric plants. And can you guys use the chat and tell me, what do you think these red arrows represent in these photographs that are up here? What do you think they represent? Forces, right, very good. So this is looking at the force. Some of this is the force of the water, and then this is the response of the forces of the dam. You see in the red arrows too. So how do engineers decide how large or strong to build the dam? Is the weight of the water pushing against the side of the dam important? Do you guys think so? Definitely is. Did you know that 1 cubic foot of water weighs 64 pounds? The weight of the water actually determines how strong the dam must be. Water pushes against the side of the dam with a certain amount of force or pressure. The dam wall must push back the water with an equal amount of force, and the dam must redirect the force of the water into the ground and canyon walls without collapsing or moving downstream from the force of the water. So how does a dam exert force on water? What do you guys think? You guys can type some answers in there. How does the dam exert force on the water? The dam must be strong and sturdy and have strong connections to the ground in the form of foundations to help it stand. By researching the size and direction of the forces acting on a dam, engineers design a structure that is able to resist all of these forces. The principal force acting on a dam is the weight of the water behind the dam. Other forces include the weight of the dam itself, and in some cases, wave pressures and earthquake forces. When we make engineering drawings of a dam, we indicate the direction of a force by drawing an arrow. And so you guys can see those arrows that are on our drawings. So let's look at the 4 most common types of dam here. So the first one we're going to talk about is right here. It's this embankment dam. It's made of earth and is also known as an earthen dam. And usually we make it from rock. And the reason that this dam is made is because it's really inexpensive. It's the most common dam that we see across the United States. It has heavy weight and large size, and it pushes back on the water. The next dam we'll look at is right here, the gravity dam. It's similar to the embankment dam because they also use heavy weight and their large size to exert enough force on the water. But gravity dams are made of concrete and considered to be more secure than embankment dams since concrete holds together so well. Because there's so much concrete needed to exert force, gravity dams can be very expensive. Gravity dams are often used in situations where extremely large dams are required and when the additional cost is deemed unnecessary or is deemed necessary to protect people and property. So this is the next dam we're going to look at. This one is the Arch Dam, and you can see it's got this little arch. It's kind of shaped like a C, right? So it has a curved shape and it's ideal for narrow, rocky locations. The shape of the curve takes advantage of the canyon walls. The curved dam redirects the force of the water into the canyon walls, reducing the need for heavy materials to hold back the water, like what we do in gravity dams. This can make arch dams less expensive to build, but more expensive to design. The next one we're going to look at right here is a buttress dam. A buttress dam supports the force of the reservoir through its bracing supports. And these are the bracing supports right here. These are these things that are leaning up against the wall or pushing back. You see the force on the arrows here? They redirect the force of the water into the stream bed where they are anchored. Buttress dams use less material than gravity dams, making them less expensive to build. So this is a topographic map of the Hoover Dam. There's a lot of stuff going on here. So let's talk about some of the features of this topographic dam. You can see right here it says Boulder Dam, and that is correct. The Hoover Dam, also known as the Boulder Dam, early on in the project. And we're going to talk about the name of the dam throughout the presentation. But you can see here is the power plant, and this is all the Colorado River that's right here. So I want you guys to take a minute, and can you guess what type of dam the Hoover Dam is? You can write your guess in the chat box. We can go back and look here. These are the 4 types of dams. We have the arch dam, the buttress dam, the embankment dam, and the gravity dam. So if you're looking at this picture, what do you guys think? Here it is right here. I see lots of arch, lots of arch, lots of arch. Are you guys surprised to learn that it's a gravity and arch dam? They went way overboard building the Hoover Dam. So they wanted to make sure that it was heavy enough to hold back the Colorado River and that that arch took advantage of the canyon, right? Because that's one of the things we learned. So Hoover's the Secretary of Commerce from 1921 to 1929, and he viewed flood control as a vital issue. One of Hoover's first proposals was a dam in the Colorado River at the Boulder Canyon. So Hoover was an engineer and a geologist. And one of the places that he went out and surveyed was this area when he had just finished school at Stanford University. So in addition to essential flood control, the dam would make possible the expansion of irrigated farming in the parched region that we saw in that video. It would also provide a dependable supply of water for Los Angeles and for other Southern California communities. And what we have up here is a primary source that we're going to take a look at. And this comes from the Hoover Archives. And this is from Hoover. He said, to understand its purpose, our people must realize that the Colorado River in its freshets from the snows of the Rocky Mountains flows at a rate as great as that of Niagara. So he's talking about Niagara Falls, right? In the dry season, it diminishes to less than 5% of its maximum flow. The purpose of the dam, therefore, is to store the freshets. He's talking about the fresh water, and the amount of water is so gigantic in its proportions that the lake created behind it is over 100 miles long and will require the entire flow of the river for more than 2 years to fill it. So Hoover's using his engineering brain to decide how this dam is going to be built and explaining why he thinks it's so important when he's the Secretary of Commerce. So Hoover founds the Colorado River Commission in 1922 to resolve interstate claims to water and electricity. So let's talk about the Constitution for a minute. In the Constitution, there are interstate claims that talk about how laws transfer from state to state, because we have the federal government and then each state has its own individual governments. So interstate claims, sometimes there's conflicting laws between states. And Hoover wanted to resolve that because there was going to be issues with water rights. So he wanted to resolve the claims to water rights and claims to electricity before they started building the dam. But before they could even start, water wars ensue in Arizona, California, Colorado, Nevada, New Mexico, Utah, Wyoming, and then later the country of Mexico. And you can see this area here on the map where the Colorado River flows through these states, and why you can see all of these states thought that they had claims to water and electricity. The commission meets in Santa Fe, New Mexico. They meet for 2 weeks, 10 hours a day, arguing about water rights. Hoover proposed dividing the river basin into 2 regions, the upper basin, which you guys can see here in blue, and the lower basin, which is in this like cream color. And this became known as the Hoover Compromise. The division of water would be agreed upon later, but everybody knew they were going to get something. The Colorado River Compact Agreement was signed on November 24th, 1922, and was later ratified by the individual state legislatures and became official on June 25th, 1929. By then, it was signed by the newly elected President Herbert Hoover. So the Boulder Canyon Project Act of 1928 authorized construction of a dam in Boulder or Black Canyon, construction of the All-American Canal to connect the Imperial and Coachella Valleys with the Colorado River, and divided the lower basin waters among the lower basin states. We saw that in the map a second ago. So we all know part of Congress's job from the Constitution is to make a budget and appropriate funds to run the United States, right? So the act that was passed by Congress appropriated $165 million for construction and stated the primary purposes of the project as flood control, improvement of the navigation of the Colorado River, storage and delivery of water for reclamation, and other beneficial uses and generation of power. The Boulder Canyon Project Act became effective on June 25th, 1929, following the ratification of the Colorado River Compact by 6 of the 7 states on the Colorado River Basin. So I want us to take a pause here. We're going to think about a question here for a minute. I've put it up. Hoover believed that the Boulder Dam project could pay for itself with interest. What interest means is we paid $165 million. That was appropriated by Congress, right? He thought that the project could earn an additional like 2% in interest just by existing, by building it. Do you guys think that the dam could pay for itself? Why or why not? Why do you think it could pay for itself? You can write it in the chat box here. So some people are saying yes. Some people are saying electricity. That's a good guess. Yep. Does anybody else have anything to add to that? Water. Good guesses. So we'll keep learning about that. We'll keep looking for it. Pay for electricity, right? So let's look at this timeline real quick. And you guys can see up here, this is a president. You should know who this is. This is Franklin Delano Roosevelt. He was the president after Herbert Hoover. So on March 4th, 1931, the Bureau of Reclamation opens bids for the building of the dam. That means they're asking all these companies to give an estimate of what they think it's going to cost to build this dam. March 11th, 1931, the contract is awarded to 6 companies for $48,890,955. And 6 companies is not the name of a company. It was literally 6 different companies that were brought in to work on this big project. On September 30th, 1935, President Roosevelt dedicates the Boulder Dam. Here he is, you guys can see him. March 1st, 1936, the dam is headed over to the federal government 2 years ahead of schedule. So if you guys think about that, Congress appropriated $165 million. It only cost about $49 million to build. So that means it was under budget and it was completed 2 years early. That is amazing for a huge project of this size, all right? In May of 1987, the entire cost of building the dam was paid back to the US Treasury with interest, just as stated by Hoover. And it was paid back by the Bureau of Reclamation renting out the hydroelectric power plants to electric companies who sold the electricity. So if you guessed electricity, you guessed right. So engineers do this really cool thing when they're building stuff. They keep a record of how things are being built. And they're called engineering notebooks. And so after the building of the dam, some of these engineering notebooks and photographic books were gifted to President Herbert Hoover. We have them in our archives. And this is what they look like. See, it's inscribed to Herbert Hoover here. We're going to get to look at some of these pictures. It's really cool to see what it looked like while they were building it. So here, I want us to check this one out. This is cool. It says United States Department of Interior, Bureau of Reclamation, Boulder Canyon Project pouring second millionth cubic yard of concrete in the dam, 12 months after the start of pouring. So the 6 companies are keeping this photographic record of where they are in the building of the dam, which is really, really cool. So now I want us to be able to see, there is this awesome video that we're going to look at that shows us what the building of this dam looked like.
On June 6, 1933, after 2 years of preparation, workers finally poured the first bucket of concrete that would build the dam's famous face. Frank Crowe now had 5,000 men working in a deep and narrow canyon. His main task, he said, was to keep them from accidentally killing each other. 65 had already lost their lives. To transport the concrete, Crowe designed an elaborate network of aerial cableways that carried material to almost anywhere on the dam site. Before long, the cables were delivering a concrete bucket every 78 seconds.
Doggone, you know, pretty tricky job. 20-ton bucket filled with concrete roaring down over the canyon just as fast as they could get it there. The fellow that was running the crane couldn't even see where that bucket was going. He was steering that thing by braille, boy, I'll tell you.
The buckets poured concrete into blocks 5 feet deep that were stacked one on top of another in interlocking columns to form the dam structure. If the builders had tried to pour one continuous concrete wall, it would have taken 125 years to cool. Though legend claims otherwise, no workers were buried in the dam's concrete. While the arch was going up, workers were constructing the 4 intake towers on the cliffs behind. 33 stories high, they would deliver water from the reservoir to the power plants under construction below.
There were things happening every second of every day down there. All the pieces of the jigsaw puzzle that had to be in place for this industrial construction to go on, it's just simply amazing.
Frank Crowe's workers were pouring more concrete in less time than anyone thought possible. He had succeeded in turning a ragtag army of unemployed into America's most celebrated workforce. On February 6, 1935, the last bucket of concrete topped off the...
So you guys can see there was a lot of stuff going into the building of this dam, right? And you guys saw that it had the 3 millionth cubic yard in that video that we watched. So let's take a look at this picture here, because this is that pouring of the dam. And you guys can see these segments where they were actually dropping it. And if you look up here, you guys can see these buckets that are moving, right? Where the red dot is there. There's one of those buckets they were sliding across that we saw in the video, right? So this is like a really, really kind of raw picture of what it looked like here as they were building the actual dam. And you heard them say that it would have taken 125 years for it to cool. So as they were pouring it in these small segments, they actually had cooling pipes that ran through the concrete to help it cool down too. If you've ever been to the Hoover Dam, it is an incredibly hot part of the country. So very, very hot. And then here you guys can see them sitting in one of those diversion tunnel pipes. They were enormous. And if you go to the Hoover Dam now, you can stand on top of them. They've built like visitor center areas, and you can look down and see how gigantic these pipes are. So it's still regaled as one of humankind's biggest engineering accomplishments. It sits in the Black Canyon. It's about 30 miles southeast of Las Vegas. I want to tell you guys it's 726.4 feet from foundation rock to the roadway at the crest of the dam. That means the highest part of the dam. The towers and ornaments rise 40 feet above the crest. The dam weighs more than 6.6 million tons. That's insane, right? And the maximum water pressure at the base of the dam is 45,000 pounds per square feet. So they ended up using 4,360,000 cubic yards of concrete in the dam, the power plant, and all of the little towers that you see. So it's a very, very large dam. They used more than 5 million barrels of cement to work on it. And anyway, so yeah, but they did finish it early. That was something else we had talked about. So let's see what it looks like in the press, because the press is always a really important part for us to understand American history. Because we have our history books now, right, that tell us the story, and sometimes they tell us different stories. But if we look at newspapers from the time, we get an idea of what people thought about different events that were happening in history. So you can see that people were talking about how Secretary Wilbur gave it the name the Hoover Dam. And this was really, really weird because nobody got projects named after them, especially federal projects. And you can see there's unofficial protests by some members of Congress. The contracts for the project will call it the Hoover Dam, and that's where the matter will rest, Secretary Wilbur said. So there's this conflict about what they're going to name the dam. And you guys can see here this awesome picture on the cover of the New York Times of what the dam looked like, right? So these pictures are actually from the Bureau of Reclamation, and they are housed in our Denver facility, and one of my friends over there helped me get them. But this is where they're testing the overflow channels. This is how they're spraying water from what is behind the dam to the front in case the water gets too high. They don't want it to go over the spillway there. And this is what it looks like from the air right here. Same, it's pouring the water in. So we get an idea of historically what it looked like at night. It's lit up. You can see water coming out of it still. It was quite beautiful. People really liked it. And then here during the day, what it looked like after it was done being built. So there's a roadway, and for a while in the United States, it was closed. It's open now, but you can see some of these like old time Model T cars driving on the top of the Hoover Dam, which is pretty cool. And you guys can do that today if you go to the Hoover Dam. And here's another picture of construction from the Bureau of Reclamation. Like as they were finishing it out, you can see the whole arch of the dam is constructed at this point. So in 1932, Herbert Hoover visits the dam and he delivers a speech. And do you guys see something funny about this picture? It's nighttime. And this guy that's with Herbert Hoover, this is Herbert Hoover right here, and this is Lou Hoover. This is Secretary Wilbur. This is that guy that said that we could name it the Hoover Dam, right? So we're going to look at another primary source here. And it says, this dam is the greatest engineering work of its character ever attempted at the hand of man. Its height alone is nearly 700 feet, making it more than 100 feet higher than the Washington Monument, and far higher than any other such construction ever undertaken. And this is part of that speech that Hoover gave at the dam in 1932. So this is more of that speech. And basically, Hoover's talking about what happened while he was chairman, and that he helped resolve these legal conflicts that came with water rights and rights to the electricity. And he talks about the Santa Fe Compact. It was the first time that a provision in the Constitution of the United States for treaties among the several states was utilized on such a great scale. So that was what we were talking about. There was a constitutional conflict with building the Hoover Dam, and Hoover helped to resolve that as Secretary of Commerce, and then he'd oversee it as President of the United States. So wait a minute, is it the Hoover Dam or is it the Boulder Dam? What's going on here? So September 17th, 1930, Secretary Wilbur announced the dam would be named the Hoover Dam to honor the work of the great engineer. That's Hoover's nickname. I called him the great engineer. After Hoover left office, however, it was called the Boulder Dam or the Boulder Canyon Dam, and that was under FDR. I know it'll be hard to believe, but there was some tension between Herbert Hoover and FDR. They didn't exactly get along. And so it was the Hoover Dam while it was being built. And then FDR and his administration renamed it the Boulder Dam. And then in 1947, a House resolution was introduced to the name to the Hoover Dam. It passed the Senate and was signed into law by Hoover's good friend, Harry Truman. And so up here, you guys can see, this is that joint resolution. This is what it looks like when Congress is putting laws through the Senate, through the House of Representatives. And so you guys can see down here, it was approved April 30th, 1947. And on the right here is this picture of a plaque. And I will tell you guys, I walked up the Hoover Dam, up and down the Hoover Dam 4 times before I found this. It is on one of the sides of the arch, kind of towards the water. You have to like lean over to see it. It's not easy to find, but it is there, and it does dedicate and name the dam after Hoover. So let's look at how the water is used today. And so this is actually from 2005. Since then, they've actually added sending some water down to the country of Mexico. So you can see here where this water is appointed, and it goes to Nevada, Wyoming, New Mexico, Utah, Colorado, Arizona, California. Oh, Mexico is on this one. So this is the updated one. So Mexico is on here, which was not in that original agreement, if you guys remember seeing. So then how is the river water used? So the number one thing it's used for is irrigation. And we can see it on this pie chart. It's the biggest part of the chart, right? The next biggest is export, so outside systems. And then other, I don't know what that means. We'd have to guess. But this goes to the thermoelectric plant. And then the green part goes to mineral resources. And this pink part goes to livestock. It means your cows, pigs, animals that are being raised so that they can be eaten later. So how do we turn this water into electricity? So we're going to take a look at that. And there's these really great videos by super fun guy. Some of you guys might watch his videos. So he got to go on a special tour of the Hoover Dam, and we'll get to follow that with him. And they talk about how water is generated in the Hoover Dam. Right.
Oh my gosh, would you look at that? Look at the size of this. We're inside the power plant, and I'm guessing those are turbines? Pardon me? Those are turbines down there, Mike? Those, oh, you said turbine.
Those are our main generating units. The turbines themselves are actually what turns the rotor and runs the generator.
Gotcha, so there you go. That's where the electricity is being made. Now show me how they make the electricity.
Basically, it takes water in an H intake tower into a 30-foot diameter pipe called a penstock. Brings the water down into around the dam through tunnels, and then it diverges off at each generating unit into a 13-foot pipe called the lateral penstock, and each one of those feeds through a butterfly valve into the scroll case, which turns the turbine, which in turn turns the shaft, which turns the rotor inside the generating unit and creates your electric power.
So the water gets sucked in, turns a propeller, sort of, and that's the turbine right here,
That's
or
correct.
This is the turbine?
The turbine is actually right here around the scroll
Turbine.
case.
See, I was saying turbine, so
That's okay.
don't tell anyone I said that, Mike. I'm sorry.
But the turbine's here, and then basically it takes the pressure of the water flowing through, turns the turbine, which transmits that energy into a mechanical energy through the shaft and the rotor.
Turns magnets or something in there.
And permanent becomes an electromagnet. The electromagnet turns through the stator coils, which transfers the mechanical energy into electrical energy. Then it flows out with less pressure out into the tailbane.
That's awesome.
Continuing the Colorado River.
Dude, look at this place.
So you guys, we can take a look at this a little bit more closely, what he was talking about. And here we can see pictures of it. And he was talking about where this comes into the intake, which is right here. And then it goes through the control gates into the penstocks. And this is where it turns the turbine and it generates the power. You can see the power lines. If you ever go to the Hoover Dam, there are just power lines just converging on the dam. And then it flows out at much less pressure than is pushing up against that dam because it's turned the turbines to generate power. And you guys saw he was inside these generating units, but now we get to watch a video of what it looks like underneath the units where it's actually turning those turbines, which is super cool.
Just look at this wall here with all the old photos, and then down there, going down some more. The adventure is never gonna stop. Oh wow, so now we're going down underneath the generating units. I see. Wow.
Everybody gets a little up over here.
Oh, it's gonna get even louder? Oh my goodness, okay, we'll see what happens. Whoa! Holy moly! Look at that!
Generator units up above in that red compartment above.
Okay.
And the water that drives it's right below the screen.
Wow, okay, so the water's going in down here. The turbines in there?
Yep, the turbine's below this.
Okay, and then, wow, that's amazing. Holy cow. And so all the slot machines are powered by this.
A lot of them.
That's amazing. Hang on a second, I gotta get a fun pic. Dude, that thing right there, that was nerve-wracking to stand next to. Oh.
So someone said, oh, can you see that if you're a tourist? And the answer is no, you cannot go down there. It's extremely dangerous where they were, where that turns. You can see how fast that was. If someone were to touch it, they could hurt themselves. I went on the power plant tour and we didn't get to do any of that, but you can stand at the railing above the generating units and you can look down at them and see them. So this is the primary parts of those generating units. And the exciter that's on there is kind of what gets it going. It's a small generator that makes electricity and it's sent up through the rotor and it charges with a magnetic field. And that's, remember when he said it changes it from mechanical energy to electric energy. And then there's a series of electromagnets called poles. The rotor is connected to the shaft so that the rotor rotates when the shaft rotates. The stator is a coil of copper wire and it is stationary, but it's highly convective. So it's moving that electricity through this process, right? The water strikes the turbine, causing it to spin. And the Hoover Dam uses something that is called Francis turbines. So that is the type of turbine that's in there. They've been there for a long time. They've expanded how many they have. And so it generates a lot of water. So let's take a look at the Hoover Dam today. Isn't it beautiful? So it's still here today. There's a great program if you guys are bored at home today, and it's called Reimagining the Hoover Dam. You can find it on YouTube. And what happens is there's a group of engineers that get together and they talk about how they would build the Hoover Dam if they were to design it today. And basically they decide to build it a little bit differently, not much. But one of the big problems that came from the Hoover Dam was some ecological problems. There was some species that popped up in Lake Mead, this big lake that's back here, some different kinds of mollusks like clams or oysters that are not native and started destroying some of the native habitat. Now you can see the water levels are incredibly low at the Hoover Dam right now. They might be getting higher, but there was a lot of droughts that were happening in California, as I'm sure some of you know. So they were using those reserves that were in Lake Mead, which was its job. So I want to leave you guys with a fun fact here. This is a memorial, and the little square is actually a gravesite for a dog. They called him Hoover Dog. He was born under the 6th Company's number 4 barracks. He had no master. Everybody knew him. Everybody fed him. Everybody liked him. And one day, many, many years after the dam was done, it was very hot, and he fell asleep under a car. Got ran over and passed away. So they buried him at the dam site. He's still there, you can see him, but he worked with all of the construction guys. He loved the dam and he lived there even after it was done being built. So that is what I have today for you guys. I'm happy to answer some questions in the chat if you guys have chat questions. If you want to ask me a question on the microphone, you can raise your hand and we can get you unmuted. Oh, so people died for a lot of different reasons, but one of the big reasons they died was that they were working in big tunnels they built and they didn't have ventilation. So a lot of men would go back to the barracks to go to sleep and they would never wake up because they had carbon monoxide poisoning. Some of the other men died kind of dangerous job site type things. A lot of men didn't have helmets. They were rappelling down the side of the wall and they would get injured. So there was a lot of different reasons that people died. People do still use electricity from the dam today. It's actually gotten bigger, so it's generating more electricity. Oh, I don't know about the revolutions on the turbine. You guys should look that up though. That's a really great question. Oh, okay. So if the dam breaks, it would send a wall of water that would be catastrophic. And that was one of the reasons they closed driving over the bridge or driving over the dam. And if you go to the Hoover Dam today, you go through security screenings so you can drive your car on the dam. The dam is sound. There's no cracks in it. It is really sturdy and really good, but definitely don't want the dam to come down. It would be absolutely catastrophic. All right, guys. Well, I think we're going to wrap it up. I super appreciate you guys coming to hang out with us today. If you have questions, you can always email me. It's elizabeth.dinchel@nara.gov. Let me see if I can get you guys back to where that is so that you can write it down if you want to send me an email. I hope everybody keeps learning. I know this is a weird time to be home when we should be in school. So my email is this, Elizabeth, and then it's .dinchel@NARA, that's NARA.gov, G-O-V. So you can send me emails and questions about the dam. If you guys are thinking about doing National History Day, I really want to encourage you to do that. Maybe start thinking about topics for next year while you have some extra time on your hands. And think about maybe Hoover, the Hoover Dam for a topic. It was super fun, you guys. I hope you guys have a great day and go watch Reimagining the Hoover Dam. Thank you, guys.